a less than ideal, but it is fine for us here. Worse for people who are not here. So congratulate ourselves. Right. My name is Oleg Šelajev. I work for project GraalVM. I work for Oracle Labs, which is the research and development department within Oracle. And we do science, right? It's an actual research and development institution. So they research what's possible in the fields of computer science and publish academic papers. And then we try to convert that accumulated knowledge to like real life software projects that will benefit the community, the ecosystem, and hopefully the parent company. Then they will be happy with us as well. If you have any questions, but you don't want to like ping me here directly, or you just want to ask later, I'm almost universally available in the internets by @Šelajev, Twitters, GitHub, email, and other things. Right. Do not make any foregoing business decisions based on the contents of this presentation. I was told that this is a very important requirement. And now with this mandatory thing out of the way, let's talk about GraalVM. How many of you have heard of GraalVM? Excellent. Not all of you, but hopefully after like 50 minutes, that would be remedied. How many of you feel that you can describe what GraalVM is? Right, one person. Excellent. Hopefully you will be able to describe it after the session a little bit better as well. Right, so GraalVM is a high-performance polyglot virtual machine for running programs in different languages, all languages, but technically and potentially, and a subset of all languages currently. High-performance, polyglot, all languages. Right, it's a runtime for running your programs, and the project has started with the compiler bit, right? So it started 7 years ago when people at Oracle Labs, Science Labs at that time, decided to write a compiler for Java in Java itself. And from there, the project grew into other areas, and now we have the fully blown runtime system. You can use it now. You can use it today. There are examples of companies and projects and teams using that for almost all the capability that GraalVM has, which is a lot. But the main benefits that you can get as Java developers or within Java teams is that it's a really high performance runtime, which means it can run your programs really, really fast. Which doesn't say a lot, but mostly it's just you would like to run your programs faster. Right? If you can run it faster than otherwise, it's a win. Everyone wants fast software. Nobody wants like slow applications. And GraalVM offers normally for many, many workloads and many, many applications a faster runtime for JVM languages than otherwise. Another thing is GraalVM offers this bit that you saw earlier, right? We can transform your applications and make it start almost instantly. 20 milliseconds, 40 milliseconds. This is the numbers for the startup of native languages, of Go, of Node.js. So if you want that startup, if you deploy into environments where that is important, GraalVM can offer you a thing and you might benefit from it. It also comes with a low footprint, but more about that later. It's a polyglot VM, which means that it supports many languages. Currently, we have JavaScript, Ruby, Python, R, and everything that goes through the LLVM toolchain, right? So native languages like C and C++ or Rust. In various stages of compatibility with the ecosystem, JVM languages as well, right? But this is given. It's a fully blown Java virtual machine. And the VM for those languages is embeddable, right? So it was designed from scratch to be put into different contexts, and you can embed that into your native or Java applications. And the last bit is the interoperability. Besides just being able to run programs in those languages, we can run them in a single process. So we can build your system in a way that different components are written in different languages because, well, maybe you want this machine learning bit here to be written in Python because Python is good for that. Or maybe you want the rest be written in Java or Node.js, right? and you can mix them efficiently. And at runtime, there will be no separation boundary between the different languages. So we can compile across the languages, we can efficiently remove all the boundary between those, and it will be a very, very efficient process. So you don't have to build like fleets of microservices if you use different languages. You can just use them and run them in a single process. So those are the things that GraalVM offers you better than, or at least comparably with everything else that's available. And we feel that in the upcoming future, we'll see more and more people evaluating, trying, and using GraalVM for those things. We can do other things, and I'll try to show you demos and explain how exactly we achieve those results, but we'll see, and we'll try to concentrate on those. If you want one picture to explain GraalVM, it's this, right? There is in the middle, there is the GraalVM runtime. On top, we see the list of languages that we currently support. And they can be run, programs in those languages can be run in different environments. We can run it in the JVM, and that will be the normal JVM, right? Typically we use the hotspot. It can run in the Node environment, and that will be the proper Node application, right? It will have the event loop, it will have the signal handlers that Node applications register, it will support the Node.js ecosystem, it will be normal Node application, but you can use all the languages there. As I said, it's an embeddable runtime, so you can put it into your like platform applications. If you have like a large application, maybe a database, some companies have databases, and you can add GraalVM to allow your software to execute programs or snippets in those languages. So we built some experimental builds of the Oracle database where GraalVM is used to allow you to run stored procedures and user-defined functions written in JavaScript. Normally you do that in PL/SQL, but if you don't feel like PL/SQL and you want to use JavaScript because maybe you are more proficient in JavaScript, you can do that. You can build that into your native applications or Java applications. I think yesterday there was a Kafka summit right here in London somewhere. I saw a tweet, wasn't there. And they showed how somebody showed, I'm sure that's not the fully production-ready Kafka yet, but they showed that they can have builds of the Kafka streaming platform where you can specify user-defined functions in those supported languages as well, right? So they took a Java applications and built in the GraalVM into that Java application, and that suddenly became a polyglot platform, right? And last but not least, we have the standalone mode, which we call GraalVM native images. It's when we compile your Java application ahead of time into this standalone binary that doesn't depend on JVM, and it's linked to the normal operating system level libraries, libc and so on. And it can be used in very small Docker containers. It can be used on the cloud environments much more efficiently. Right. So this is one picture. If you want to remember one slide, this is it. If you want to remember one URL, it's graalvm.org. If you want to remember one Twitter handle, it's @Šelajev. Personally, I'd be happy to point you towards other things. When you download the binary, right, if you want to try it, you will see a picture like this. You will download the binary, you will unzip it or untar it, and you will see something that resembles your normal JDK distribution. You will have all your normal Java commands there. There is Java itself, right? There is Java C, there is Java P, there are all the less frequently used commands like JMap and so on. It's a normal, proper OpenJDK or Oracle JDK-based distribution. But besides that, you will also have the command line launchers for other languages. So you will have the Node right there, and you will have the R somewhere on the top. I'm not sure what's the sorting here. You will have the JavaScript utility to run JavaScript. There is Ruby, there is LLVM interpreter, right? So imagine this, we compiled your native code, your C code, through LLVM. We take the bit code and we can execute on the JVM. And it will run, and we can make it run in a sandbox mode, like in a safe managed environment. So all your like incorrect wild pointers that corrupt data will be transformed into like normal Java exceptions that you can handle. That's not the most straightforward use case, but we can do this, right? And that just shows the versatility of the platform. So you'll see this, right? And all those tools will be for you to experiment, to run, and to use them. Some of them come in a kind of like a plugin component-based system to keep the standalone initial base download a bit smaller. Because if you cram into one space a JVM, Node.js, and Ruby, and their native libraries, and Python, and everything else, it becomes a little bit too fat. So there is a GNU utility which can download certain jar files from GitHub, for example, and put them into the correct places. So you start with a base download, you run GU install Ruby, and it will get the Ruby bits, and so on. Right, so this is what you get, and this is what it looks from the inside out. When we run your program, there are layers, right? Software is like a lasagna. And those layers are the platform. Normally, if you run in the context of the JVM, remember that the left bottom bit when we run on the JVM, the platform will be the Java hotspot VM, your normal Java, and it will do the normal things that Java does. It will start, it will boot, it will load the JDK standard library, it will initialize all the necessary things. Then what we do, we plug the GraalVM compiler into the JVM. We plug it through the JVM CI. JVM CI obviously stands for the Java Virtual Machine Compiler Interface. And that is the interface that you would implement if you would like to create a third-party compiler for the JVM. This is what everyone implements when they want a third-party compiler for the JVM. As far as I know, it's us and maybe a couple more teams. But this is the standardized interface. It was added to JDK 9 in a JEP 243. And we just add like a jar file there. With that, the GraalVM compiler will become a top-tier just-in-time compiler for your JVM, right? That will mean that at some point of time, JVM will look at the code and say, oh, compiler, here's the bytecode, here's the profile. I executed those branches or something, and please give me the machine code. And the GraalVM compiler will take the bytecode, will look at the profile, will optimize the code, will output the machine code, and then the JVM will run that machine code. Right? So that's normal way how the just-in-time compilation works and how JIT works. GraalVM compiler is not an exception there. And just through those two layers, we can run everything that runs on the JVM normally. Everything that compiles to the JVM bytecode, we can run it. Because the GraalVM compiler is excellent, we can run it really, really fast. Right. For other languages, this is not enough, right? So normally, to add support for other languages, you would need to create optimizing compilers for those languages. You would need to figure out how to translate the concepts of, say, Ruby. Like, what does it mean to have like a Ruby block or like a Python list comprehension? And you would need to translate that into the JVM bytecode or any like low-level representation on any platform. Right? If you want to port your language to .NET, you will need to figure out how to translate your language to the common intermediate language, like bytecode of .NET. Right? If you want to pass it through LLVM, you need to take your high-level language and translate it manually to the LLVM bitcode. This translation step is hard. It takes effort, and it takes a lot of effort to maintain that because languages evolve. Some of them evolve like JavaScript really, really fast. Some of them evolve not so fast, but they change. So you often and always will need to keep this compiler bit intact with the language. To build the universal VM for all the languages, we couldn't go with that approach because that will be really, really very hard to keep up with all the languages. So we did a different thing. We created the Trussell Framework, which is a framework for implementing managed languages on top of GraalVM. What it offers you a certain API to describe an interpreter for your programming language. So you build an interpreter that operates on the abstract syntax trees. This is what people do in the initial compiler courses in the university. So you write a high-level program that will be inefficient. It will evaluate every single operation as a virtual call, right? It will have a tree, there will be nodes, and every node will say, oh, let me evaluate myself. And to do that, let me evaluate the children nodes. And for every small operation, you will have a number of virtual calls, and it will work. It will fix the semantics of your language really well because you describe it in a high-level language, but it will be very slow. But with the GraalVM compiler techniques and with the Trussell Framework, we can, at runtime, look at those trees of the interpreters and we can optimize them currently at runtime only, but we can squish them together and remove all those indirections and based on the profile, create really efficient machine code for your particular program that you're running through those interpreters. And with that, we got support after the framework is done. We got support fairly easily for different languages, very dynamic languages, and they show really good potential, and they are running faster than competition, I think, except JavaScript, because V8 is a really, really good virtual machine for running JavaScript. But we are very close to V8, so it's a great feat. Right, the native bit here, right? People often ask us, why do we need a virtual machine to run native code? It's a little bit of like a nonsense. You specifically compiled everything ahead of time from C to have this efficient binary. Why do you do that? And the answer is very simple. Very often in the dynamic languages, you will have the native extensions. You will have parts of the modules of the ecosystem that is written in native code to help performance. So to run, say, like a Python module efficiently on the JVM, we need to be able to run its native bits on the JVM as well. So for that, I think that was the original inspiration for the LLVM interpreter, but we got it working. So now when you run Python, and say you run NumPy for machine learning or for data processing, the native bits are running inside the same process as well, with the same guarantees and boundaries. So this is how it works. This is how it works. There are layers, and they all depend on each other. The good bit is that this whole thing can run on other implementations of JDK as well, right? So Trussell is a bunch of jar files. Ground compiler is a bunch of jar files. LLVM interpreter and interpreters for those things are a bunch of jar files. In general, the whole project is written in Java, which is excellent. It also means that Java developers can just go look at the source code and feel like they kind of understand what is happening there. I'm not claiming that any Java developer would immediately have like a good understanding by just looking at the code, because it's like building a compiler. It's hard work, right? You have to have some expertise, but at least the language will be the one that you and I understand and deal with daily. At least the tooling is there to like load that into your IDE and go click through the class names and find which bits use what, and you might get much more familiar with the technology. So GraalVM is an open source project with the main repository being Oracle/Graal. It's fully functional. You can build it. It's available with reasonably permissive open source licenses. I think most of them are similar to their original counterparts. So Java related bits with the same licenses as OpenJDK, Node.js related bits as Node.js, Ruby, and so on. Right? We try really our best to be like a good citizen of the open source community. And personally, I think like we kind of do a good job there. I hope. I would like to think that. Right? So you can build it and you can get the binary. If you don't want to get the binary, build the binary itself, you can download our binaries. There is a community edition which is available from GitHub. This is what you get if you build those things. And there is an enterprise edition which is a proprietary product by Oracle, and it comes with a different Justintime compiler. So the compiler has more optimization phases, and it's usually universally faster than the community edition, right? So the community edition can provide you with performance boost, and the Enterprise Edition will provide you with even more performance if you want to opt into it. They're functionally equivalent, so anything you can run on the Enterprise Edition, you can run on the Community Edition. So I would recommend to maybe evaluate that, but maybe start with the Community Edition if you want to test the waters or the polyglot programming, and then figure out whether you need additional performance or not. Just recently, just last week, you can see I reused the slide. It says launching today. It was launching last week. We released that as an official product with Oracle offering support for it, for the Enterprise Edition and everything. So this is a very good sign that the project, the GraalVM project, is here to stay for ages, right? Because it's going to be supported until the heat death of the universe, or any other major disasters locally in the solar system or something. So it's an official product, right? So, which makes us very happy because it gives us the path to monetize the effort. There was like 70 people on the GraalVM team inside Oracle, which is a massive investment, and having a clear path to monetization, especially an opt-in path, is a good thing. Right. With all that, now this is the theoretical part is over. I'm going to try to do a couple of demos. I'm going to show you what GraalVM can do. And we'll take it from here and we'll see how much time we have, and we'll see what we can do and what we can see. Right. So I have my GraalVM thing here downloaded. And if I do ls minus everything in the bin directory, you can see this is actually the slide that I showed you, right? So we have our Java here, somewhere here, Java. We have other commands. We have installed all the languages here. And when I also added that to the past. So if I do which Java, it gives me my GraalVM Java distribution, right? If I do Java minus version, you can see that it's built based on Java 8, which is, I think, one of the latest JDK 8 builds available. How many of you run Java 8 in production? How many of you run Java 9 Plus in production? Nice, 10%. Perfect. How many of you remember the year when Java 9 was released? 2 years ago, 3 years ago, 5 years ago? I don't know, I don't remember. But we backported the JVM CI interface from Java 9 to Java 8, and we provide builds based on Java 8. We would like to provide the builds based on Java 11, and then potentially keeping up with the ecosystem further. But there are currently certain components of GraalVM which are not there yet technically. So the compiler, the GraalVM compiler bit works, and I'll show you that as well. But there are no pre-built binaries that you could use. So, but luckily for us, majority of you run GraalVM, run Java 8, so it could be the drop-in replacement for your Java, right? So let's see how it behaves. I have a series of examples here. And we'll start, and I'll try to go and show maybe bits of for those value propositions that we saw earlier. So let's start with high performance bit. I told you that it can be faster than normal Java, and I'm going to show you a micro benchmark which supports this, right? So I will show you this, and I will run this benchmark, right? It's a very simple one. It's written with JMH. What it takes an array of integers, and then it just streams that, and it applies a couple of lambdas as map transformations, and then reduces that to a single number. Not the code that you typically write day to day for a living, but kind of represents maybe more modern Java 8 based workloads. Most of you, if you're running Java 8, probably you use Streams API, probably you use lambdas here and there. So this is a typical benchmark. I just like it because it runs fairly fast. I mean, it just the whole thing runs in a couple of minutes. I will run it. I will run my Java from my GraalVM home distribution. But one thing that I will do initially, I will disable the JVM CI compiler. So I will explicitly say, Java, please do not use the JVM compiler, so it will not use the GraalVM compiler. It's a normal JDK, and the Graal compiler is enabled there by default, because it's, well, our builds. But here I will disable it for you. We disable it, it will run for 40 seconds. It doesn't use the JVM compiler, and it runs that. Let me open a different IDE for this, because I would like to show you the code there as well. Right. Open folder. While it runs, I'll just open this in my well, open. No, not the single file. Open the whole folder. GraalVM demos, right? This open. Right. Excellent. So we have it here, right? This is our source. This is our code, right? This is the benchmark we're running. We can see that it takes approximately 200 nanoseconds for an iteration of this test method. This is normal. This is how I presume all of you run your Java now, or like in a very similar manner. Now, I will do this trick. I will not disable the GraalVM compiler, and I will run the same benchmark. And what I will do while we wait, I will not show you the numbers as they come, because I don't want to spoil the results. And we will wait 30 seconds. And while we wait, so it's not really boring, I will ask you, who thinks now it will be faster than before? Who thinks it will be slower or kind of the same, 200 like nanoseconds per operation? Very smart. I will not show you the benchmark where we are slower. That's not going to happen. Come on, it's a demo, right? But like, how much faster do you think it will be? 10% faster or more. 10% is a lot on the JVM, right? JVM is a state-of-the-art virtual machine. Maybe 20% faster or 50% faster. Who thinks it will be twice as fast or faster? You're optimistic? 4 times as fast? That's ridiculous numbers. You understand that? Like, it can't, like, nothing can be 4 times fast as JVM, because JVM is a state of the art. Like, it's the fast software. That's why we use JVM as a platform for running software, because it's fast. It's also a synthetic benchmark, but you can see now. So when we finished, and you have to understand that the numbers below are just data. So you have to understand what is happening. But this benchmark, one iteration, runs in 10 nanoseconds. Let's be generous with error. Let's say it's 20. 200, 20. That is 10 times faster on this individual benchmark. I don't want to claim that your software will become 10 times faster if you just swap the path to our Java rather than Java that you are currently using. That's not what's going to happen, most probably. Because in a large system, there are, well, this optimizes very efficiently on GraalVM, right? Because it's a small synthetic benchmark. Compiler can see through it. Compiler can optimize it into almost nothing. It probably won't happen in your large applications. But the key bits of your applications, right, which are compiled with the Justintime compiler, they will become much, much faster. And it can give you a great performance boost, depending on the actual workload and your actual hardware and how you actually, like, what your application is doing, what data it is processing. We have a question.
Yeah, I mean, nowadays all microservices are just like eating JSON from A to B. So is there any like performance improvement, for example, on the space libraries, which are actually, for example, JSON parsing and so on? What can I expect there? Because I probably don't have many of these streaming stuff in my microservice, and there are mostly IOs. Things involved, etc. So what would be like general guidance if you look to this benchmark with whatever?
With the normal production software, yes. The question is, what would be the performance impact on the normal?
Yeah, especially some of these standard libraries. I mean, there are all these standard libraries, for example, for JSON parsing.
Yeah, absolutely. right? So the general answer to that is, as always with performance, it depends. So you shall measure, you shall run the benchmarks, you shall run your performance tests. We see great results. We see a little bit different results based on the programming language, for example, that you run. Anyone runs Scala? 2 people. Like for Scala, we show amazing results. Scala bytecode patterns are different from what normal Java bytecode looks like. It like a valid bytecode, but like because Scala abstractions are different, the bytecode patterns are different. So on Scala, we have great results. Like you should use it or at least try it without even looking back. Twitter is using GraalVM compiler for running their Scala microservices. So when Twitter is down, it's not us, it's something else. But they are very happy, they talk about that, and I'll show about this. So on the normal benchmarks, it depends. I don't think I have a slide, but recently I saw like a benchmark suite. And benchmark suite for the modern open workloads, right? And this is where, it's a shame. It's a shame. Do I have a picture like that? Right. Let me just do this really quickly because it's the background is what needs to wait. What I want you to see. Save. Don't be silly. Right? Come on. This is fine. We are not here for the pretty slides. We're here. No, we need the legend. Wait. Right. Right? Boom. We have the slide here. Don't mind the title. So we run the benchmarks for the normal libraries and frameworks that you probably use in production, like all kind of akka stuff and all kind of log libraries and some Scala and some reactive libraries and some PageRank and some Neo4j analytics for the like memory bound workloads and some other things. Some Bayesian logic there, right? And this is written using normal libraries that you currently use. The slide comes from Renaissance benchmark. It's renaissance.dev. And you can see that normally the GraalVM, both the Community Edition and Enterprise Edition, are outperforming OpenJDK on most of those workloads. The Community Edition is volatile. Right? It's sometimes much faster. Sometimes it's on par. Sometimes it's a little bit slower. Here, for example, or like here, a little bit slower, right? So it's volatile. We run internally tons of benchmarks, right? Because we deal in the high performance virtual machine. We run them daily. And we know that if you take all the benchmarks and you collapse the results into a single number, Community Edition comes 1% faster than OpenJDK. Right? So it's faster on average, but it's volatile. Sometimes really good results, sometimes not excellent results. So you have to understand what you're doing if you want to use the Community Edition and you want to get the performance boost. You will probably get it, and that Twitter supports that, but Enterprise Edition of the GraalVM will be universally faster, right? So it will enhance your JVM and you can use it and speed up your workloads even without understanding what you're doing. But as a product. So that's the difference, right? But in general, please measure things on your workloads. That's the most precise way of doing that. So we run a bunch of benchmarks. We blogged about that. We blogged about which optimizations help GraalVM compiler to be as efficient on that. So we have really good inlining, which is the main base optimization that helps us. We have really good escape analysis. So if your application generates objects, we are very good at that. Not actually allocating the objects. So streams and high-level abstractions benefit from that a lot. Scala benefits really quite a bit. Both the compilation times, because Scala compiler is a Scala program, so it can run faster, and the actual runtime. Oh, I do have the bench. I do have the slides. Look. So we do that. We try to make it really, really good. The team is committed to make GraalVM the fastest runtime, best-in-class runtime, right, for all languages. So we should be the fastest Python. We should be the fastest Ruby. We shall be the fastest JVM on the market. And then Enterprise Edition can offer additional things, right? This is another thing. The OpenJDK builds includes the GraalVM compiler, open source version. 2 open source project, friendly open source project. OpenJDK takes the GraalVM compiler, put it in, and you can run your OpenJDK builds. I think it was 9+ or 10+, don't exactly remember. But currently, if you run Java 11, for example, what you can do, you can unlock experimental VM options, use JVM CI compiler, and you will be running a version of Graal compiler inside your OpenJDK. It won't be the latest and greatest. They pull periodically the GraalVM compiler sources into their OpenJDK forests, and they build it into a component in there. But you can run it, and you can see the performance boosts and speed up. So one example is, we run benchmarks for that as well. So say you have a matrix multiplication like this. And again, don't trust any individual benchmarks that anyone is showing you, but try to reasonably approach to this data, right? If you run this with the JDK 11, and then you will run with JDK 11 and GraalVM compiler enabled, you will see quite a bit of performance boost, 2x. The Enterprise Edition is still faster, but the main benefit comes from here. There is the benchmark, the complex numbers are written in the immutable fashion, so every math operation generates a new object, because that's how we would like to write our software. We would like to be able to reason about things that we write. And immutable data structures are easy to reason about. But unfortunately, they generate tons of garbage, so that could be hard. Well, the GraalVM compiler has a really good escape analysis, as I said, so it can see through most of that and not actually allocate objects, and that's why it comes with a great performance boost on those workloads. Even the version in the OpenJDK bit, which is great, which gives you an easy way to try it. Right, Twitter is using that. They're showing good numbers. Recently, in the previous versions, it was a jar. Yeah, I said the Graal compiler is a jar file, right? It was written in the in Java. So what we did recently, because we didn't want to compile the Graal compiler when it just starts the JVM, because it's a jar file, so you need to compile it. We compiled it ahead of time into the native executable and plugged it into the JVM as a native library. So now there is a native version of the GraalVM compiler inside the GraalVM builds, and then the speed up and the startup of that a little bit faster. So it was slower before, and now it's comparable with the normal setups. Right. Now I don't think we have quite a lot of time. So I pose you a question. We can do and look at the polyglot bits, or we can do and look at the startup bits, like the instant startup low memory overhead things. Probably low overhead instant startup because it's a DevOps thing, right? Startup, not the startup when you build a company and sell it, but like when you run your process. Right. So our JavaScript is great and fast. It runs. Ruby is fast and great. R is great and fast. Python is the youngest, so we are working on compatibility with the ecosystem first, targeting NumPy, SciPy, machine learning workloads. You can use tools for languages, but let's talk about the GraalVM native images, which is the mode of execution when we can transform your program and build a native executable. It's a fully ahead-of-time compilation of your program. Since we have a compiler, a just-in-time compiler, you can think about it as a function of 2 arguments, the bytecode and the profile, and it outputs the machine code, right? If you don't give it a profile, it becomes a function of 1 argument, the bytecode, and it will output the machine code, right? It's like how the type signature works. So what you can do, if you have a just-in-time compiler, you can give it a non-existent profile, no profile at all, and you will get some sort of machine code. Normally it would be like a fairly mediocre machine code because the compiler will not be able to use their normal optimizations and speculate based on the profile because you didn't give any. But still, functionally, right, it will work like this. So GraalVM compiler can be used as an AOT compiler ahead of time. You give it bytecode and it gives you machine code. And it has to be configured in a special way to be reasonable when it does the AOT compilation, but it can do that. And what you can do, you can compile your code, and then instead of running it on the JVM, where the JVM bits are pre-compiled, and then your Java code is loaded as class files and executed dynamically, it will be just purely pre-compiled machine code for your platform without the dependency on the JVM, right? Only just this thing. And it will work like this. You feed all your application, all your classes to the GraalVM compiler. And there is a utility to do so, so you don't have to actually like manually feed every class through like cat my class files pipe something. It will take your application classes, it will take your dependencies classes, it will take the JDK standard library, all the Java code that will ever be executed. It will look at it really, really hard. It will find the bits that will actually be used. And then it will compile that ahead of time. It will pre-initialize the data structures, and then it will produce an operating system wrapper around that to allow you to actually execute that thing. It can also do shared libraries, but most typically you would like to have an executable binary to have your program run in this native image mode. Right. There is a catch. This technology, the GraalVM native images, are available as an early adopter technology. You can use it, but it's an early adopter thing. And it comes with a certain things that you have to configure, because we do this analysis of what will be executed statically, right? We look at your code. When you call method object A.b, we can see that classes A and B will be used, right? So we can analyze that and we can include that in the final binary. If you use something dynamic like reflection, static analysis cannot figure this out, ever. It's just impossible. So you as a developer have to provide hints which classes you use. So you need to provide a JSON file that says, I want to include that and this in the final image, in the final executable. If you use resources like images or JavaScript files, you don't use them through like java.something something notation. You use them through class loader get resources, get bytes or something, right? The static analyzer cannot know about that. So you have to say like, please include that JavaScript file. It's important. Or your favor icon or something. And JNI and other things. So as a developer, you have all the knobs that you can make it work. And you can even do this configuration by running your normal Java process and using Java agent to provide this configuration for you. Right. The benefits of that are immense. Your Java application will start in absolutely no time. Well, it will start in a little tiny amount of time, a few milliseconds. And because it doesn't have to have the machinery for processing class files anymore, because everything is compiled ahead of time, the runtime memory overhead will be much lower than normally. If you run in the cloud, if you pay for your startup costs, like something as a function as a service, or like Lambdas, or something like this, serverless frameworks, startup is really important. That could be great. If you pay for memory, and in the cloud you do pay for memory, maybe you don't need to use this for the application just processing some class files, right? And there are frameworks and libraries that kind of adopted this approach. Quarkus by Red Hat, and they offer integrations with other popular libraries. And they use GraalVM native images as the platform for applications. Of course, they can run it on normal Java as well, but they support compilation into native images. Micronaut by Object Computing. Helidon by Oracle. I think even Neti recently included the configuration for the GraalVM native images into their artifacts to help you generating things, to say like where they use reflection and stuff. So the ecosystem is catching up. It's a very exciting thing. We are working on the Windows. There is a very experimental build of the Windows binary that you can download, try, generate Windows command line utilities with the native image thing. We are working on Java 11-based builds. As I mentioned, the compiler works, right? The Justintime compiler. But this native image thing is not technically there yet. We are actively working on that. And it's gonna be great. So the more people use this, the better this technology will become. Right, so we are out of time. If you want to learn more what GraalVM can do for you, I will be here for a little bit more time. You can also check out the blog posts at medium.com/GraalVM, where the team actually publishes things about what we can do and what they think you should look at when you are experimenting with GraalVM. And one of the first blog posts we published was the top 10 things you can do with GraalVM. Surprisingly, not everyone on the GraalVM team knew at the time that you could do all those things with GraalVM. There are a lot of things you can do, from native languages to using compiling as shared libraries to everything. So this might be a good starting point into your journey into GraalVM. And as always, you can download it, you can try it. It's a high-performance polyglot virtual machine for running programs in all languages, with the most popular currently supported out of the box or as pluggable components. So try it, give us feedback, tweet at me how much faster your applications became, especially you Scala people, like after the conference, not immediately, not right now, but after the conference. And just know that GraalVM is a project that is here to stay, and hopefully the ecosystem will be friendly to us, and hopefully we're going to have a very bright future together. Thank you.